So this video is going to be covering chapter 10, section 4, which is about changes of state. And before talking to you about the changes, I'm going to tell you what a phase is. A phase is any part of a system that has a uniform composition and it has the same properties. So for example, you have a solid phase and a liquid phase and a gas phase. And there's also plasma, but we're not going to be talking about it in this lesson. Okay, let's say you have solid, which is ice. And you know that solids have a definite shape and a definite volume. So their particles are stuck together and compact. And they cannot move except for vibrations. And let's say this is ice. And then for liquid, we have water in the form of the liquid that we drink. The particles are not very stuck together. They can flow over each other, and they are fluid. So they have a definite volume and an indefinite shape. And gases, let's say in the form of water vapor, are very far away from each other, their particles I mean, and they have an indefinite volume and an indefinite shape. Okay? Now let's say you want to change from a solid to a liquid. How would you do that? You have to add energy by a process called melting. Like when you change from an ice cube to normal water, you melt it. And from liquid to a gas, you boil it or you vaporize it. So it's vaporization. And that's how you change from water to water vapor, through boiling the water. And from a gas to a liquid, you're supposed to remove energy from it. And that's by a process called condensation. So the water condenses, the vapor, I'm sorry. And from a liquid to a solid by freezing, as you know, by removing energy as well. Now let's say you want to change directly from a solid to a gas, like dry ice to carbon dioxide. It's a process called sublimation. And from a gas to a solid by a process called deposition. And that's when you change from carbon dioxide to dry ice. And that's it. So the second part of this lesson covers equilibrium, which is the condition in which two opposing changes occur at equal rates. Liquid-vapor equilibrium develops in a closed system only, and here only liquid is present. And you can see that some molecules are beginning to evaporate. Over here. They're further away from each other. And in the second one, let's say that the molecules are very close to each other at the bottom, so they're in a liquid, and they're starting to evaporate over here. So this part is a gas, and this part is still a liquid. So evaporation here is happening at a constant rate. And we emphasize on constant rate because this is what equilibrium is, basically. And some water vapor molecules are beginning to condense. Back to a liquid. In this flask, equilibrium is reached. And we have further away molecules from each other. Here they're in both a liquid and a gas together. So equilibrium is reached between the rates of condensation and evaporation. And as we knew before, condensation is when a gas turns to a liquid, and evaporation is when a liquid turns to a gas. And you do know that in evaporation, the process occurs at any temperature, so it doesn't need to be hot or boiling to evaporate. Another issue in this lesson that relates to equilibrium pressure is equilibrium vapor pressure, which is the pressure exerted by a vapor in equilibrium with its corresponding liquid at a given pressure. So let's say that you have a liquid and its intermolecular forces are high. And for example, an ionic compound, so you have positive and negative forces between all of the atoms, and they're held together very tightly, let's say. So in an ionic compound, it will be very hard for the particles to overcome these charges and evaporate. So you're only going to have a small number of molecules over here, like you're going to have one or two, versus, for example, over here, where it's all going to be in equilibrium quickly. Over here, where the liquid went into equilibrium really quickly, the liquid is called a volatile liquid. And because they're only held together by London dispersion forces, which are the weakest kind of forces, and volatile liquids evaporate very easily. Okay, so now we will discuss boiling, which, as we said before, is the change of state from liquid to gas. So it's basically when a liquid, so let's say here, a liquid, okay, gets hot enough to the point where gas and vapor start to form within. So like let's say you're boiling it right now. This is fire, excuse my drawing. Okay, you're boiling it right now, and bubbles start forming within the liquid. So it sort of like steams up when the bubbles get to the surface. And yeah, this happens at exactly the boiling point, which, for example, for water is commonly known 100 degrees Celsius. And the boiling point is the temperature at which the equilibrium vapor pressure equals the atmospheric pressure. Okay, so when liquid reaches the boiling point temperature, the temperature becomes constant. So for example, if you get to, let me draw a tiny graph, bigger. Okay, so let's say after a couple of minutes, this is temperature and this is minutes. So after a couple of minutes, temperature kept increasing and then reached to, let's say, 100 degrees in water. It got to here. It doesn't just continue increasing. It just becomes constant and stops. So the exact opposite of boiling is freezing, which, as we mentioned, is the change of state from liquid to solid by removing heat or energy. So let's say you have a beaker or whatever this is, and it has a liquid inside it. This liquid is being frozen, so imagine it being inside a freezer. Okay, so the liquid's particles simply get closer to each other, so these become these. Let's add more of the substance. Okay. So yeah, this change also becomes constant and stops freezing at a certain point. So there's also a freezing point, which is like when the liquid turns to a solid, just like in the boiling point. The substance changes from this to, say, 0 in water, from 100 to 0. This is boiling and very hot. This is not even boiling, it's a gas, so say like that. This is not accurate at all, but then it just stops freezing. It just remains as a solid. That's it. Okay, so we spoke about melting, freezing, vaporization, and condensation, but what happens when there is a low temperature and pressure? Well, the answer is easy. A liquid cannot exist. Equilibrium happens between gases and solids and gases under these conditions. So there are two processes, as I said before. There's sublimation and deposition. Sublimation is basically when a solid turns to a gas directly, and deposition is its exact opposite. It's when a gas turns into a solid directly. Now, one of the common substances that this occurs in is dry ice, so one of the common substances in which sublimation and deposition occur is the solid form of carbon dioxide, or dry ice, which looks sort of like this. It's really cool, and it's usually used in like exotic dishes where fruits are put in platters and stuff. This is put under it. Chefs usually get like courses to learn how to deal with dry ice. So yeah, thank you for watching, and I hope you learned something new.